Welcome to today's webinar, New Features in RFEM 6 and RSTAB 9, our new program generation. My name is Andreas Hörold. I will be the moderator today, and I will also present some new features together with Andreas Niemeyer. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, press releases, the German and English webinars, etc.
Hello, my name is Andreas Niemeyer and I'm responsible for the development of the main programs, the RWind product and form finding applications.
Hello, my name is Oliver Metzkes, and here at Dlubal I'm working as a product and customer support engineer, and today I'm answering your questions from the webinar.
Hey guys, my name is Daniel. I am an HR manager for a German company and also responsible for the marketing and the customer support. Dear engineers, users and fans of Dlubal, enjoy structural analysis. I'm sure there are some in the audience who will agree with me that structural analysis and design are enjoyable tasks indeed. Develop structural concepts, calculate models, and design structural components. It is even more enjoyable when the tools of the structural engineer also work really well. Probably the most important tool of an engineer today, besides a calculator, is the software. We at Dlubal Software also make a contribution here by providing you with a complete package of structural analysis and design options. Now, with our new products RFEM 6 and RSTAB 9, we offer you exactly that and usher a new generation of structural analysis programs. In doing so, we always remained true to our slogan, enjoy structural analysis. Structural analysis can and should be fun. Therefore, it was also one of our major concerns to incorporate customer requests such as the improvement of our printout report into the development process. Basically, we can classify our innovations of our new generation into 4 categories. First, new programs. Next to RFEM 6 and RSTAB 9, we have also R section, which merges our previous cross-section programs Shape Thin and Shape Massive to one product. Secondly, also RWind 2, which can now also calculate transient wind flow for more accurate detection of turbulence and gusts. Secondly, new add-ons for the design, analysis, and special solutions. I am particularly proud of our new masonry add-on module, which has not yet been available on the structure analysis market so far. There we consider the nonlinear material model with a brick-mortar combination. Furthermore, also our new add-on steel joints, where you can now analyze any steel connections using an FEA model. Third, new features in the program, whether it's the faster calculation or the much faster printout report with increased layout options, or also the integration of all our add-ons into the main programs. Fourth, new features in the add-ons. We improved and modernized our add-ons, and there we have, for example, in the analysis of construction stages and significant improvements, like the consideration of structural objects of supports now. Or, and there I'm also very proud of that, the provision of the 7th degree of freedom to consider warping torsion and the entire model. There are many more innovations in the software. So now I hope you enjoy our webinar, join our journey with a new generation, and you will see RFEM 6 and RSTAB 9. Their structure analysis will be more enjoyable from now on. And with that, I now hand over to Andreas.
Okay, thank you, Daniel, for the introduction. Maybe some general information. You can ask questions during the webinar using the control panel. You can see that on the right side of your screen. Open that with the arrow here, and then you can ask questions here. Now, if you don't get an answer during the webinar because there are too many questions, you will get an answer via email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, at first I will go through these 3 points here in the PowerPoint presentation: new features in the main programs, the new standalone programs, and the new add-ons. And then we will turn back to the first point, and we, Andreas Niemeyer and me, we will introduce some features in the program. Okay, yeah, only some features here. We describe the most of them directly in the program, but it was important to me to add here the links to the website where you can find more information. Under for RFEM 6, the second point here, you can see a lot of features, and in this webinar we will introduce only some important features. But you can use the links when you download the slides after the webinar. At the end of the webinar, I will show you how you can find the slides. Okay, second point, new standalone programs. As already mentioned from Daniel, our section, a combination from shape thin and shape massive for thin mode and massive cross sections, and the stress analysis. Then an extension of our section, effective sections for the design, for example, for cold formed and thin mode, our section cross sections. Then our wind, not only with stationary incompressible turbulent wind flows, now also with transient wind flows. Then the web service and API, a programmable interface for RFEM and RSTAB. Andreas Niemeyer will show you the web service or parts of the web service later in the program. Okay, new add-ons, the steel joint add-on, all steel connections by using an FE model now. As I mentioned, more information with this link. The building model, to define and manipulate a building by means of stories. You can consider and display story masses, and it's also possible the output of section resultants in global direction for determining shear forces. Those features, for example, are quite important for the dynamic modules or dynamic add-ons. Now we have got add-ons. Then the new add-on masonry design using the finite element method. A non-linear material behavior is considered there. Then two more add-ons, optimization and costs, CO2 emission estimation. For example, you can use this model to optimize models using the artificial intelligence. I think a very interesting program. Then time-dependent analysis, to consider time-dependent material behavior of members. Okay, then we turn to the program. We will show you some features. Andreas Niemeyer will start. I hand over the screen to him. So, Andreas, let's go.
Okay, thank you. Moment, yes. So let's go. I'm coming to the first block, and I'm proud to get the time to show you the first scenes of our new program. And I opened for this our base data dialog, because here is the basic key of our new RFEM6. Generally, you see this base data dialog, it's almost similar to our old solution, but it isn't. If you watch here, you see you get here a bigger list of tabs where you can define something. And this I want to show you now in the next few minutes. At first, before we start, we give a name, of course, like always, maybe intro. And here is our first new bigger change in the program. You get now as engineer new type of models, or let's say calculation environments. Of course, we offer here, let's say, the basic plain options, plate options, and maybe member or axial solutions. But you get here, besides this pure plane, also a plane input mode with a 3D calculation. We call it internally 2D, 2.5D mode, but this option is available for the plane, plate, and axial solution, and gives you the option that you can calculate plane structures with asymmetric cross sections with loads out of plane in one calculation environment. And the keyword for this is, for example, if you want to design a wind bracing of a steel hull with not with tension members and with truss members from angle cross sections, then the angle cross sections can bend out of plane and you get the real stresses on these members. But for our presentation now, I go back to 3D and open the next sheet here. And this sheet is, let's say, the key for everything. Here you define your task, what you want to do in the RFEM6, and we distributed it here into, let's say, 3 main parts. Yeah, you get now here add-ons, our old so-called add-on modules, here analysis add-ons, design add-ons, and let's say special solutions. And this is our complete list of add-ons now. We got in past some customer feedbacks that we offer so many add-on modules, and it's not clear which add-on is for what, and so we summed up all this stuff into this list here. And if we take a look maybe on, for example, steel design, we have now one add-on for steel design with all standards. Before it was like you have one add-on module for Eurocode, one add-on module for US standard, and now everything is in one package. Steel design makes the steel design for all foreign standards what are available in the program. And this logic is quite bigger as it seems now when we take a look on concrete design, because here in concrete design you have also, let's say, all standards behind and also all type of elements, maybe punching nodes, members, and surfaces also. So this is now a clear, cleaned up list of add-ons, and you see directly what is possible, what could be done with the program in this sheet here. For our presentation now, let's take a focus on steel design and define in the next sheet the standards. You see here you have a standard list. You can set it up. You can define here maybe different Eurocode annexes, but also different standards. Here in this case for combination, and for steel design the same. You have all available Eurocode annexes and also different standards. So you can decide if you want to design it here in Germany, in United Kingdom, or in Russia, for example. This is contained in this package steel design. And I selected like this here and set up my list for standards, which will be used for the complete calculation in RFEM6. And now I open the program with this specification and want to give you a first view how it works together. If we open now RFEM6, it looks in the first view like our last generation, but let's say we changed on a few points something. For example, here in this navigator structure, we created now a navigator with, let's say, a cleaned up structure, what means we have now basic objects like node, lines, members, and so on, and every basic object have specific types. For example, if we go to nodes, we have here type for nodes. It's the same for members. If we go to members, we have type for members, and all this type for members could be assigned to any element. And the same logic you will find here in the table block below with these two multi-combo boxes, where you can see you have your structure and also basic objects and type for elements. And this should help you not to lose the red line in the program. And now, how you work with the program. Let's define one member, for example, with a specific cross-section, going to library, going to, for example, role cross-section. Let's select an AGI 200 from steel 355, for example, and select it. Then you see you can still pick the grid points like you know it. In the old program, you can define a beam. Of course, you can also place now supports on the end of the beam by drawing a window about. And even it's still possible to place a load on the beam here. So for example, 10 kilonewton per meter. So this should give you the information if you are able to work with RFEM5, you are also able to work with RFEM6. But now there is a specific point where a change is coming. In the program, RFEM6 always prepares everything that you can do directly at design. This means after the load input, it's ready for designing. So if you go to calculate, the program creating mesh, calculating load cases, creating design situations for the design, and doing a design. So you see all steps what are done now, and it's ready. So we get, as expected, for the load case, what is selected on the top, the deflections. We get, let's say, forces. Let's use the wireframe model, and we get also a design. So we have here now a combo box where we can select the design, and you see this is the utilization curve of the design, the steel design in this case. You can see a ratio of both, but you can also see only cross-section check or serviceability check, or all together, all lines together in one. This is now only the graphical depiction of this problem, but we can also display the detailed results in result tables. And this is now new. It's not drawn into a window above the model. It's implemented into the main program. So you get the design ratios as ratios or table rows in the main program by a table design, maybe table by design situation, by loading, or by member. And if we go to member, you see all checks what are governing here. And if we select one, we can go also into details and see which figures leads to this utilization, which forces are used, which section properties are used, which classification is done, and which figures with hind to standard chapter leads to the utilization. And because this was also a little bit cryptical, we implemented or invented now also such a formula display where you see the full calculation of the utilization like a hand calculation with a clear description of all used variables and with filled values. So you can say, please show me formulas without and with values. And this is a really cool style to display how the design is done without the black box character. And this is not only here for steel, then for all type of materials we support. So even for concrete, for aluminum, for timber, whatever. So this is now the new style of display of design checks, how it's done in the program. And if you need more details on basis of cross sections, you will find always this button here where you can display the utilization on basis of cross section for a selected X place. Here you can not only display utilization, then also the existing stresses for the forces what are acting here. In our case, we have maybe here a bending moment of almost 60 kilonewton meter, or also a shear stress, and you can display it on basis of cross section here. This brings me to the end of the first block, and I give back to Andreas.
Okay, thank you. I show my screen. Do you see my screen? Andreas, do you see my screen?
No. Now.
Now, okay. It took a while. Okay, but as I mentioned, we alternate the presentation. Some features from Andreas Niemeyer, some features from my side. I go back to the base data, the fifth place from left here. And yeah, Andreas Niemeyer already showed the dialog, but not the model parameters. I would like to show you some more features here, or a very good feature. The construction site can be specified on a digital map. I can open that map, and this data is in turn used by the load wizards. Some of you knows that page here from our website. I enter our location, our main office, the address of our main office in Tiefenbach in Germany. Then I get the snow load zone free, and what is important for our calculation, the characteristic value of snow load, 0.51 kilonewton per square meter, the wind loads and the seismic loads. And then I can apply that, and the program reads all parameters for the wind load wizard, snow load wizard, and in future also the dynamic values. That's still in work, the seismic loads, the import of the seismic loads for the dynam modules. Okay, that take some seconds. The website seems to be a little bit slow at the moment. That's why it takes some time. Now we have to wait. That's the connection between website presentation, GoToWebinar tool. Sometimes some processes take quite long. When I don't use the GoToWebinar app, that takes only 2 or 3 seconds. So it doesn't seem to work at the moment. Maybe I come back to this feature later, because there's a problem with our website, I assume. Okay, I cancel that. And jump to the next feature, the load transfer surface. If you have such a model, for example, with slabs and walls, but you don't want to define all walls because here is a glass facade, then you can use this new feature, the load transfer surface. I will show you how to do that. I open here a new rectangular surface and the new stiffness type load transfer. So a new dialog is open. Then load transfer direction. You need to define the direction in X, Y, or both directions. It's also possible to set a surface weight if you want to consider the weight of the glass facade or trapezoidal sheets, etc. Then I apply that and create the surface. Okay. Then a small wind load, new surface load. For example, 1 kilonewton per square meter, Y direction. Okay. That's the load. And if you want to see the line loads, the separated loads, then turn to the display navigator and under surfaces, you need to select display load transfer separately. And now we can see the line loads here. And it's easy to change the direction by double click at the surface, then here load transfer in Y direction. And now the line loads are visible here. Okay. Then, I hand over the screen to Andreas. I take a look at the first model in the meantime, what is wrong there, and then we can turn back to this model later. Then, Andreas, please continue.
Okay, thank you. Then let's go ahead. I prepared now a model for you, two-story solid model from concrete and steel elements. Even I used here is just shown load transfer surfaces in windows on the roof. So I think it will solve us a lot of issues and save time. But this is not the point here. I have prepared this model now to show you how we can specify the design of elements. And maybe take a closer look on the beam elements here. And if you take a look on these beam elements, we have now inside the building here concrete beams on columns and on the roof some steel beams here, truss girders and with bracing. So typical structures what we see from our customers. And now the question appears, if we have to design, for example, the truss girders, we have to specify that the upper chord is supported against lateral deflection on this, let's say, mid node. And as you saw on my first presentation, the program always thinks that the design is done for the element and prepares everything. Of course, it needs sometimes more information. And if you have to give more information, you can double click on the elements and you will get in the property of the element you selected all design relevant options. So here you have some sheets where you can, for example, define the effective length, boundary conditions, local section reductions, shear panel, rotational restraint, and so on. For concrete, it's something different. And now the task is, you see, we have two apertures, so I have to make a multi-edit and can select both and can change both. But this is now one step, what is questionable, because you can assume if you have a bigger model, you don't see all similar objects, and therefore we give you now a new function on the hand to solve this. If you go to base data back, you have here a settings and options tab where you can activate member representatives. And if you activate member representatives, you get now let's say a sum up of all elements, and you can visualize it here. And the program visualize on all elements now such a colored bubble. Let's select maybe the red one, and you see the program automatically recognize that these two elements are similar. The same for the, let's say, vertical elements. It recognizes that these elements are similar. And this means that the program found out from our members, so we have here 31 members, that we have 10 similar groups, and these 10 groups this information we can use for specification of design properties, we can use for documentation, and we can use for pure calculation. So this is a pure information what helps us also again to save time. And now back to our primary task to assign some properties. I can go now, double click this red bubble for the aperture and go into design types and go now to my task to assign some backlink definitions with using the representatives. And now to the next feature. If we want to define backlink lengths, you know, as engineers, we want to define backlink lengths and segments. So if we watch this element here, we say, okay, this aperture is supported here, and we have one segment here and here. And for this task, we prepared now these effective lengths types or templates, or I call it now check it because I like this term for it. So we create now, let's say, a backlink type check it, what we wrap then around these beams. This means we say, please check backlink about Y, about C, about torsional backlink, about lateral torsional backlink, do it with eigenvalue method, and please make a fixation on the start and end node of the element, without knowing how long the element is right now. And because we want to apply it on these apertures, we say, please do it for this type. And you see the program realizes this type have 3 intermediate nodes. So I say, let's fix the intermediate node. This means for the backlink definition, we have one segment for the strong axis, 2 segments for the weak axis, and 1 segment for the torsional checks. These factors we can increase if we have maybe a restrained fixation or something else. And we can also define that this fixation is on the upper or lower flange. And now we can define this, let's say, backlink definition as check it for these 2 members of the representative 1. And if we confirm it and display these deal types in the main program, you see the program supports or segment this aperture here on this point on where it supports the second intermediate point. If we want to support, for example, also the first one, we can open this setting. Let's go to the steel types, to effective length, and say, please check also the first one. And if we confirm it, we get also a fixation on this point and can visualize it also. So we don't have now to define any numbers on the members. Then we create the hull or a check it, which we pull around the representatives or members in one step. Because this looks so gritty, I remove it now, and okay, and both are updated. The same logic, let's say, for these types, we can use also for concrete. So if I go, for example, here to the beam and say, I need another reinforcement, not a buckling design, I go here to longitudinal reinforcement and say, I don't want to have here 3, then 4 rebars with a diameter of 20 and confirm it. And then the program also updates here this setting for all beams what are connected to this representative. And this brings me now to the end of this part. I only want, and for me it's important that I could show you, you can define now all this design relevant data in the main program by using all tools of the program plus this new representative logic. Okay. And I give back to Andreas.
Okay, thank you. I show my screen again. Okay, I imported the data again. Yeah, it took 2 seconds without presenting my screen. It's real strange. But now I would like to show you the real advantage of this feature. I go to the load wizard, the snow load wizard, for example. Yeah, that's the same wizards as in RFEM 5. So, but I will show you some features. So that's quite the same, selecting the edges here or the corners. So yeah, one feature is you can deselect areas. Yeah, that's not so important, I think, for the snow load generator, but for the wind load generator, for example, imagine you have got a neighbor building here, and that's a face here, and you don't want to consider wind loads on that surface. Then you can deselect the face, and no wind load will be generated. Okay, I select the nodes that should get any load. I go to the navigator views, and then I select members by type, the trusses and tension. Yeah, the tension and truss beams. Okay. So that's okay. So, and that is the real feature, the import of the location data and the parameters of the location, the load zone, free, the altitude, and the characteristic snow load. That's the new feature. Of course, you can define snow loads also manually. Then snow overhang and snow guard, it's still there, or it's possible to consider. Then you can log for new objects if you add new objects later, but these objects shouldn't get any load. You can select this. Then you can consider member eccentricity. For example, a member is outside the selected area, but it's inside because of his eccentricity. Then you can select this to consider this beam, or you can consider, for example, here with the last check, tapered beams. Okay, the program suggests to create free load cases. The second and third one is for half snow on left or right side. I deselect them. I would like to only get this full snow load. Okay, so, and that's the next very important feature. the surface loads here and the member loads. Yeah, it's a hybrid model, and RFEM consider this. Okay, that's all to this feature. I come to the next feature with the next model. Surface contact. Yeah, a surface contact describes a contact property between two or more surfaces that are at a distance from each other. And yeah, important, or that is the difference to RFEM 5, it is no longer necessary to create a contact solid between the surfaces. I go to special objects here, surface contacts. And as I mentioned, you can select one surface here, but also a group of surfaces. I select this surface and the opposite surface. Okay, then I need to define the surface contact type. Yeah, the most of you knows who worked with the contact solid in RFEM 5 knows the options here: full force transmission, failure under compression, failure under tension, for example, the rigid friction, and I leave the friction factor as it is. Okay, and you see here the small lines, and that means there's a surface contact. Now let's check this. I create a load here, nodal load, only a small horizontal load and a larger load in Z direction. Okay, and then we can calculate the load case. And the upper plate, should moved in opposite direction. Should lift a little bit up. When it's finished, we take a look at this. And as you can see, this plate here lift a little bit up because the failure under tension. Okay, that's all to this model and to this feature. Next feature is rigid link. Usually we connect surfaces by axis, but if you want to consider the thickness, I show you what I mean. Under rendering, model, solid model, surfaces, you can see the fillet surface, including thickness. If you want to consider, for example, a weld here and don't want to connect to the axis of the surface, then you can use a rigid link. Also under special objects, rigid link. 3 options here: line to line. If the opposite line is already created, then line to surface, then the line in that surface will be created automatically, and you can consider a diaphragm. I use line to surface, this line here, and this surface, and the line in the surface will be created automatically, as I mentioned. Okay, the rigid link is created. We can calculate all. I already defined a nodal load. I can show you that. That's the nodal load, and as you can see, it works. Okay, I turn back to the steel hull. I calculate the snow load case that I can show you the next feature, the result diagram. We implemented some new features. you can display the overlapping of results. For example, if you have similar structural components in one model and you would like to analyze that. Let's select these 3 horizontal beams. You can see here's only a smaller load, and that's why you can see a good effect. I select this member set, this and this, then right click, result diagram. So, and I check here MY. Now you can see the 3 member sets consecutive, but also overlapped. That's an option. That's the left member set with the smaller deformation and the smaller MY. Then we can show that overlapped and enveloped only the maximum values of the deformation and the moment of the 3 member sets and overlapped description. Other old features, for example, smoothers, are still implemented. Okay, but a very important feature is that you can work parallel in the program and in the result diagram. If you have 2 screens, you can move the result diagram to the other screen, and I think that's a quite good option. Okay, then I hand over the screen again to Andreas Niemeyer. Okay, Andreas, you can continue.
Okay, thank you, Andreas. Then let's go from this detailed analysis according contact issues back again to maybe complete structures. And I constructed now here one structure, what maybe is not a really structural analysis problem, but I can display or present you this new feature quite good on this type of model. Basic is that we have here members and here shells, and as you see, I defined here directly imperfections. And this is the keyword. I want to show you how we implemented or how we reinvented imperfections in RFEM 6. And imperfections now will be organized in individual imperfection cases. This you will see here on top in this list box. So in past we did this with load cases, and now you get individual imperfection cases for this. And here 2 cases in X and in Y direction, and these imperfection cases are organized between the model data and the load data. So the place is exactly here in between, where we have these 2 cases. And these 2 imperfection cases could be assigned to, let's say, load cases and load combinations. The place is here, so let's take a look on load cases. You get now an option to assign here to any load case imperfection by check and by selection, and the same here in load combination. In this special case here, this imperfection cases or the allocation is great. The cause is because all these load combinations are generated according a wizard. So he decides which imperfection should be used. And this is maybe even a feature now how we can learn our wizard which imperfection should be used for which combination. And this was in past even let's say a quite exhausting step, and we improved it a lot. So if we go back now, you will see that we learn now these imperfection cases assignment to a specific load case. So here I can say imperfection X works together with wind in X, and imperfection in Y direction works together with wind in Y direction. And this allocation have now some effect for the program or for the wizard for combining the load cases together. And let's take a look back to this menu. And yeah, let's open the load combination sheet, and you will see the list will be reduced. And let's take a look what happened now. So for load cases, I call it symmetric load cases, maybe sulfate, where we have only vertical components, we get, it's not clear which imperfection should work. So the program allocates one in X and the same for Y axis. The same for snow load. So if we have surf weight and snow load, we have here one imperfection in X and one in Y direction. But until we get one load case into the combination, you will see you have here a wind in X. So you see the program allocates directly an imperfection into X. The same for wind in Y direction, we have an imperfection in Y direction. And with this logic, you can assign imperfections quite efficiently by giving only the governing load case into the allocation and getting a combined result back within seconds or fractions of seconds. So this is one feature. But now if we watch the model, you will see, or the question could appear, we have here imperfections, in this case global imperfections on members, but what is with shells? Can we also incline shells or not? In past it was not so easy possible, but now we, let's say, extended these imperfection cases with imperfection types. And one imperfection type is, for example, here this initial sway via table, where we can say the building is running in, so this elevation is running in C, the imperfection should run in X. We have maybe one ordinate at 0, and the building height is in this case 4 meters, and the imperfection is, for example, 200. And with this definition, the program knows now, I delete this because it's covered, that he should create a geometrical imperfection for the calculation of the load cases with the sizes what are defined in this table. And here we can create geometrical imperfections not only for members and also for shells, so for everything together. And the program inclines it with this imperfection magnitude. And this is not a deflection, and this is only a picture of the deformed mesh what is used for the geometrical nonlinear calculation. So this was one basic feature I want to show. And the next feature I want to show is our new printout report. For this new printout report, I prepared a file or model, not a regular model, so it's curved and don't fit into all these rectangular shapes, only to see the limits. Yeah. And if we want to create a model, we go the navigator one stairway, not up, in this case down, and create here a new printout report. This step leads us into a selection. So here I can select what should be mentioned. So every check stands for a spreadsheet. I collapse it here and say, please show me for the static analysis only the summary. For example, I reduce this table, and for the concrete design, I only want to see from the results no warnings and only ratios by members, ratios by surfaces, and the reinforcement will be covered by pictures, for example. And if we start the generation, the program have now a bigger change in relation to the old program. It exports the data into the environment of the printout report. So there is no direct bidirectional connection, then we export simply the data into the report. So these applications are working parallel. What means we have here the report and we have here the main program. This is one feature what helps you to set it up, but also this stuff you get now a designed report with content, with let's say explanation pictures in the right scale, with information about everything you defined, about the concrete cover, about the durability classes. All this stuff is explained and prepared for your clients in a nice shape. But of course, we know such a report only works if we have pictures which explaining the results and model. So you can improve it by pictures, and let's do this. So we print now a few pictures, for example, one of this model. And if we print this picture, we implemented now something like a preview. So we say, please print the current picture, not tiled, and as 3D picture as window filling. Yeah. So now we have it. So as window filling, so we get this picture 3D, I can explain afterwards, and we print this picture, how we see it now, into the report. I don't have to show, I can only confirm it with okay. Then we make maybe a detailed picture. Here we implemented also a new feature. For example, we can say, please show me the concrete type, the reinforcement. Let's make here transparent model, and we want to give a specific section of our graphics into the report. So we can go to the printer and can say, please make a defined area in graphics, and we say here, nope, please print us maybe this section where I can give an explicit definition in graphics, and the program finds the right scale to print only this what I selected in graphics. And of course without 3D options. And now I can move this into the report. And if we go to results, this is also possible. So we can say, please show us results, maybe only from the ramp. And we make a top view. Yep, with results. Or not concrete results and static, and maybe the MX results with values on surfaces, and we want to print this picture. And if we go to the printer, we get again our preview. You see, in this case, the program tries to find the right scale, but I think the scale is not optimal because it's too small. So I say, please use scale. And 1:50 is okay, but it don't fit on page, so we use full page. Maybe it makes it better. But as expected, it makes it not better. So we have here a new tiled option. So the program creates now tiles according to the defined scale, 1:50. And you see, we have here also an overview sketch, and the program creates a picture with overview sketch with the scale what is defined. And this is nice, but now we realize as engineers, we not only need MX and also MY. And this is no problem, because you can extend it to a multi-print, go to results and select MX and MY or more, what you want. And if we go back to the preview, the program updates the preview with these more result types for the specification what we made about tiles and scale and so on. And we have now a preview picture, a longer preview picture with all results. and this we can move into the report. And now the program updates the report, what we already generated, and brings in these pictures, what we just printed. So you see it's opened, we can use it. It's not maybe freezed or something else. You have it already here for further usage. And after all pages are printed in, the program, let's say, updates the content to have real figures in it. And now it's ready. So we have all pictures there, even these multi-pictures are there. There's no performance leak or something else. But it seems good. This 3D picture have a different icon here. And now we can say we are ready, but maybe we need some additional information. So we collapse all here and say we need a new chapter. For example, create folder below, maybe add-on. And we can create here some new folders. We can place it here in between. Can change the numbering by moving these chapters, and we can also insert some new stuff, maybe formulas or also a PDF here into this report. For example, we have here some reinforcement description PDF, and we say we want to have here this page and this page, so 7 and 8. So let's open this PDF with page 7 and 8 and store it into the report. It places it below the last, but we can move it in our add chapter, and then we have here even these tables from the PDF in our document. And now to sum it up and to finalize this report stuff, we can print the PDF and store it here. Maybe we overwrite the old file. And because we implemented this PDF printer directly and don't use a free PDF printer, we are able to create PDFs, which have here a document structure on the left side. And here we can directly jump to the chapters and even to our pictures. So you see also the Adobe Acrobat Reader have some performance leak here, but it depends a little bit on this picture, because the user or the reader of this document can also rotate the model here because we printed it tridimensional. And this is, I think, a really advantage for your clients and good to present your work. And this brings me to the end, and I give back to Andreas.
Yeah, the improvement of the printout report is a very good feature. But yeah, I can show you also a very good feature. That's the faster calculation, especially for RFEM 6 and RSTAB 9. We developed the solver manager. This enables the calculations to be carried out in parallel. I start a calculation here, and as you can see now, for example, 4 solvers, 1 per core, can calculate 4 different load combinations at the same time. You can see that a little bit here. And when it's finished, blocks then are finished here on the left side. We can wait a short moment. And then you can see that more than 1 core calculates in parallel. And of course, this leads to a better utilization of the cores and thus faster calculations. I think that's a quite important feature. Okay, then maybe some smaller features. Sometimes it happens to me sometimes. I create a load, but I'm in the wrong load case. That's easy to change only by right-click edit the load or double-click at the load. You can easily change the load case here. I don't want to do that. I need the results for the next feature, the clipping box. I show results. So And if you want to see only parts of the model, then I can use the clipping box. You can find it under guide objects here, clipping boxes. Double click. I need to select the middle of the clipping box, maybe the middle of the column here. Then the dimensions of the clipping box. And then you can see only parts of the structure. For the analysis of the results, it's a quite good feature. And you can disable this box by right click and switching off the box. Maybe only a small forward feature. You can decrease or increase loads by right click. Only the display of the load, of course, not the value, and the display of supports. Line supports, surface supports, and nodal supports, of course. Okay, that was this feature. And I hand over the screen to Andreas Niemeyer for the last part of our presentation. Okay, Andreas, you can continue.
Okay, thank you. Last but special, but gives you a lot of power in your hands. I want to lose now a few words about our programmable interfaces. So RFEM 6 is ready to be controlled by your code, and we offered here 2 code options. So I describe it now with Windows. So everything what is done inside RFEM could be done by a JavaScript coding. So it offers you to create your own function. So if you want to do something, you can create your own JavaScript function. For example, you need a function to let a load running over the beam here. So it should act here in one load case, in the next here, in this load case, here and here. So you can ask, of course, our Dlubal support if we have an add-on for this, or you can program it by yourself by JavaScript coding. For this, we implemented here a console and a manager. The manager offers you some examples, but also a chapter where you can place your own functions. I placed it here below function, and I wrote it down with a few lines code. Maybe here, let's open it with an editor, where you see I defined here for my task a few variables, the size of load, how many steps, which element should be loaded, and a loop, what is creating load cases and member loads with type force, concentrated distribution, global coordinate system, direction C, load magnitude, and the distance from start. And if we double click on this function, the program will move it into the console and run this stuff, and nothing is blinking or something happens, but the program creates us here below load cases some load cases where the load with the size, what is defined in variables, is running over the beam. And you see it was not more than 20 lines. And if you don't know any command, or you want to know the commands, you have here in the console this info button, where you see the full package of all commands to add-ons of design, concrete design, geotechnical analysis, whatever. If you want to define a node comment, you click here and get the command how you have to write it in the script. So nothing complex. I think every engineer can learn it. No problem, I think. This brings me to the end of this JavaScripting, and I go over to the global interface. So if you have a wish to control the program from external side, maybe from Excel, maybe from AutoCAD, maybe from your database on the other side of the world. It's possible now because we connected our program to web services. You can set up a server, a RFEM server or Dlubal server by this function with specific port, and this allows you to connect to this server and send commands and receive commands. And because it's a web service, we allow now the interconnection of different applications over networks of computers, also over internet. And to give you an easy interface, or not interface is wrong word, wrong term, to give you an easy option to set up such programs, we offer on our GitHub channel for Dlubal Software a Python interface or Python package, which you can download here. And with using this package, so it's a folder which contains maybe the interface data in the same logic like we organize our data in main program. So basic data, type for lines, type for members, as I mentioned at the beginning. And you get here for every element what you can connect to the option. And if you open, for example, one in the editor, you see the logic, how you have to write it. For example, for defining a node, number, coordinate X, coordinate Y, coordinate Z, comment, and so on. So it's not a big deal. And if we run here, for example, an example, you have here a folder with examples. Here's one program for creating a cantilever. And I only create a new file, so that we can close. Maybe open an empty sheet here in RFEM that you see how it's working. No. Okay. So we have an empty sheet here, and let's go back to this program and double click this program. It's starting, it's connecting to server. It's resetting model. It asked me about the parameter. Maybe we want to have a 5 meter long cantilever beam, and the force should be 15. And now the program is modeling it, calculating it, and give me a sign when it's done. Ready. So now we have a cantilever with a load of 15 with results. So this should show you how easy it is to create models from an external source in RFEM, and it's also possible to get results back. And this brings me to the end and maybe giving you some ideas. So with this technique, you can create your own skin over the program, can create your own tool for designing your repetition parts, for example, windows, anchors, consoles, whatever you sell, for example, and can offer your clients, for example, a website where you can define it and you can make an in-time design and offer them a best solution, for example, or you create for your engineers the tools only for this stuff what you are creating. All this stuff is now possible, and maybe it inspired you a little bit. And I give back to Andreas.
Okay, I hope you liked some of the features or all features that we presented. At the end of the webinar, I would like to show you where you can find the recording in the next days and the models and the slides. You will get an email that leads to that page here. You can find it also by clicking through our website, news and events, webinars. That's today's webinar. You can find the presentation slides already at the moment, and in the next days you will find the recording here and the models that we presented. I would like to invite you to the next webinar, Modeling and Design of Steel Structures in RFEM 6 and RSTAB 9, next Wednesday, 2 p.m. Yeah. Then I would say thank you, or would like to say thank you for your attention. Thanks to my colleagues for the support, for the presentation, and for answering the questions. Maybe only one hint: when you leave the webinar now, there's a small poll with 4 questions. Yeah, it's quite important to our quality management. Yeah, I can show my webcam again. Yeah, and yeah, just note that the worst score is 1 and the best score is 5. Yeah. Then have a nice rest of the day. I say thank you and bye-bye.